Hello everyone, welcome to my 25th live stream, I think. The plan for today is to finish the Rust stuff. Again, the Rust stuff, but yeah, to finish the MG client. Actually, it's finished, but yeah, I'll present the what I've did, what I did so far, and yeah, actually try to build the query builder for it based on it. Yeah, we'll see how that will go. But yeah, I plan to finish actually today. Obviously, that's gonna be a bit longer stream. So yeah, hopefully that's gonna be fun. We'll see. And yeah, as always, please like, share, and subscribe to stay in touch. And yeah, please ask questions, put comments, suggestions. That's always welcome. Yeah, let's if that's it, let's get started. So yeah, I'll switch here. So first, let me check where we stopped last time. Just to go to the repo, not Mage for now. Rsmg client. So we have that pull request. So here we did a couple of things. Last time we polished. Yeah, we stopped somewhere here, and then basically after that, I just changed build script and the GitHub Actions script. I'll quickly go through both of that just to present. Let's click here. Let's jump here. So yeah, this is the regular stuff, and then okay, let's first go to the build part. Yeah, here. So initially, the whole build script was super basic. We just created like the binary and the library based on the statically linked MG client, I think. But that got much more advanced now. So before I introduced the whole bindgen stuff here. So bindgen is actually generated, and it generated every time these files actually change. That wasn't the case before. The whole bindgen file was just hard coded into the repository. But yeah, that was here from before. But last time I introduced CMake create, which is actually a proxy wrapper for CMake stuff. And since MG client is built by using CMake as well, then we can build that directly from here. So now the whole project is built entirely from this code here. And basically that happens here. Under the default config on Linux is super simple. We just call CMake build MG client, and the build script knows how to build MG client, and it also has part here which is also important. So we added let's say search path for these libraries. So by defining this string here, Rust actually knows how to where to find the MG client libraries, and then we specify here that MG client will be statically linked but the dependencies, crypto and SSL, will be dynamically linked. So that's the current decision. I think that's the wisest decision we can make, since MG client is more or less static code. It doesn't change often, and I think it's okay to recompile the whole Rsmg client code in case MG client changes. But these SSL stuff, they should be dynamically linked, because if there is some update or something, we should be able to reload the whole application and library. But okay, so these are stuff necessary to build MG client from here and then link it from here. In addition to that, we also added Windows and macOS specific stuff, and that's a bit more tricky, because on Windows we are using MinGV to build MG client, so that has to be defined. But other than that, that's it. And on Mac is a little bit more trickier, because for some reason CMake cannot find OpenSSL libraries easily, so that has to be configured here. And these things are very simple in general, so we are just looking for that OpenSSL library. From my experience, I'm not sure. That's a question. I'm not sure if these seller OpenSSL libraries are coming every time with Mac. It seems they do, but I'm not 100% sure. But yeah, that's how it's configured right now. And in addition to that, then the CMake has to get these defines. And yeah, so yeah, CMake create was very convenient, and it has all. Sorry. It has all required stuff to configure the build. Yeah, that's more or less it. Just a second. Okay. Okay. So that's about it. In addition, so yeah, here we have like enum for host type, but that's super straightforward. Nothing crazy here, except these configure macros here, which check for the target OS. And yeah, so this allowed us to compile on different platforms. But in addition to that, we also built actual binaries here. So where is that? So that was at the beginning. Just comment on that. So here we have a couple of things. So on Mac, the whole Rust setup and the toolchain setup is very straightforward. Basically the same as it is on Linux. So we just are installing Rust by downloading Rust up and running Rust up init, and that's it. That's the same as on Linux. On Windows is a bit more tricky, because we need Windows GNU target, and we need these GNU files on Windows. So this part here is just installing just installing the target toolchain. So this here is actually called host triplet, and it defines which what's the target build, and yeah, we need to install that or add that to Rustup, and that's done here. This is some code taken from the actual Rust repository to do some stuff on actions, but yeah, nothing really important. And I think the whole thing should work even even without these things. But yeah, and then we need to install the environment, and by running these commands here, we are installing basically SSL and CMake and the toolchain, so GCC and compiler needed to compile MG client. So this part here is required to build MG client on Windows. That's a bit tricky, but yeah, it's required at this point. And then we add that to the path. That's fine. And yeah, once that's done, we can just build the Rsmg client. This part is here interesting because for some reason, when I add the target to the Rustup, the default target still stays the same. Actually, whatever I put here under default host and whatever I put here, I get the same result. So I put here explicit target. So by putting this target command here, Rust build will use PC Windows GNU to build stuff. Yeah, and that's basically it. So that's the whole Rsmg client build. So soon we're gonna commit all that, and then we're gonna publish the crates and everything, probably next week. And yeah, that's about it. Okay. Now it's the whole API is let's say defined, and our Rsmg client will be ready super soon. But then the question is, what do we do with it? So we can use Rsmg client to build stuff, build applications, but that can be quite messy because a developer has to write Cypher queries manually and then execute them. So usually there are wrappers around these drivers and clients. So the whole SQL ecosystem, let's say, has these ORMs, so systems that maps relational stuff to the objects in the code, and in the graph ecosystem there is a term called OGM, Object Graph Mapper, and that's quite convenient to have because it's much easier to use these constructs that OGMs provide. And my goal today is to build a Rust OGM, or at least start going towards that direction. The first step is to introduce a query builder. So rather than writing queries, a developer can write regular Rust code, and that will generate queries under the hood without knowing the exact syntax of queries. So I've already created a repository called Gasoline, which is inspired by another repository called Rust Diesel ORM. So this is basically a Rust ORM, and it seems very popular. But yeah, I'll try to do equivalent for the graph stuff. Yeah, I'll try to. So I'll actually try to juggle between what they do here, how they design the API, and what we already did in this repository. So GQL Alchemy is our repository to in the Python ecosystem that does similar things. So that is a query builder at this point. So basically, as you can see here, you have so this is the basic example that imports Memgraph and executes query. So here is the query, as you can see it. But the query builder stuff, so we just create a Memgraph object, and then this object is a global object. And if we run match and then node to node execute, that will actually under the hood create a query and execute it against the database instance. So yeah, that's the goal. Actually, I haven't spent much time researching out Diesel, so we'll see how that is gonna go. But yeah, I have no idea how we're gonna do that actually, but we're gonna figure out. Yeah. Derive. Yeah, we have a lot of Rust stuff here. That's gonna be interesting. Derive, insertable, la la la. Okay. All right. First things first. Let's try to set up and actually use the MG client in another code, and then we're gonna go step by step and try to build more advanced stuff and more useful stuff. All right. So this is Rsmg client. So if I go here and run cargo build, that works. Okay, great. Workspace. I need to clone that repository. Code. So we have here all these repositories. I need to clone gasoline. So let's do that. Can I get the Rsmg? No. Okay, let me just replace this with get. Yeah. All right. We have the repository cloned. But I'll just make my workspace file very similar to MG client. Gasoline. Okay, so we have session name is called gasoline. And we're gonna clone from gasoline. The rest is gonna stay the same. Okay, great. Now we have the workspace. Okay. First things first, we need since that's the Rust project, we need the crate file. So we're gonna reuse the the one from the client. We're gonna have similar to this. Yes. Oh no. Sorry. Okay. Here we're gonna do gasoline 0.1. Okay. We need some text here. I'm gonna reuse this. Apache 2, Memgraph, gasoline. That's gonna be also gasoline, Memgraph, OGM, query builder. Categories database. Let's leave it just like this. Exclude, that's fine. For the build, yeah, dependencies, we're gonna ignore all this. Dependencies. So here we need Rsmg client, and I think we can put reference local there. Yeah, I think we can just put a local path. Yeah. Yeah. We go one folder up and we put Rsmg client here. Yeah, whatever is there. Don't need this. Cargo Husky, I think that's fine, but we're gonna add that later on. No fine line. Whoa. Okay. Why is that so broken now? Cargo built. Boom. What? Field parse version requirement. Rsmg client for the parent. Oh. Why is that a problem? That's not great. Fail to parse manifest at gasoline. Yeah, that's the general statement, but parsing major version number. What? All right. Unexpected problem. let's try to Google this error because I don't understand what exactly is the problem. Mm. Mm-hmm. What's the actual issue here? That's I think fine. What if I put here like the path equals interesting. Interesting. It seems that works now. src main lib section or bin section. Okay. src main dot rs. All right. Let's try to make a simple code. I'll just copy paste an example from here. We're gonna delete that later on, but just to have something quick and dirty. Sorry. Oh. All right. If we compile now. Yeah. That's interesting. Why that path didn't work? If I go here, specifying dependencies, so we can do that. Yeah, carrots. We don't need that for now. It seems that yeah, we need to use path. It doesn't work without path, which is fine, which makes sense. Because otherwise Rust is expecting okay, we actually target debug gasoline. Yeah, connection refused, so we need a memgraph instance fire memgraph. Now we have memgraph up and running. If we do this, boom, it works. Okay. So we successfully linked current version of Rsmg client into the gasoline project. So that's great. And then we're gonna do what we're gonna do. Now we have to actually do some design work. We have to be sure how to properly design these things. Yeah, since I have no idea, I haven't checked, I haven't done any research. I'll do that right now, trying to figure out how we're gonna actually design the API and what's gonna be our design decisions. Let's just first check the GQL alchemy. How is that done here? So we actually have a connection object which essentially has all these connection parameters and has these methods to execute stuff. And then we have that's like abstract stuff. Then we have Memgraph connection that implements all that, which is fine. and then convert memgraph to value. We are converting these objects into our objects. So relationship, that's a models file, and we have here our object. So okay, okay, let's just start here. So just to write these things. So implement the connection object. Objects. Okay. That's fine. What else? Connection has path relationship node. Sorry. If you are here, models, we have graph, node relationship path. Graph node. Okay. Constraints and index. Okay, these are the models. Query builder, what's that? So I'll just list all these things that we have to build, but later on we're gonna decide how actually we're gonna build that. And yeah, what is that? Query builder stuff. So here, partial query. That's interesting. That has more logic into the whole thing. So the query builder stuff actually match types. This has more logic about the Cypher. So assume the whole point here is to have all the Cypher logic. So we're gonna just put implement the query builder object. That has a lot of logic. We're gonna go through that. Yeah. Transformations. What's that? That's network X specific stuff. I'm gonna skip that. That's not required for now. And utilities. These are two Cypher labels. These are serialization primitives. So whenever we have a value, we have to generate a Cypher value, Cypher compatible value in the query. So each value is serialized in a certain way, and also then the whole value plus property has to be. Yeah, I'm gonna just add here implement serialization part. So that has two Cypher value. And then we have two Cypher properties. To Cypher label. Great. Okay. No, we're gonna get here later. Memgraph. What is Memgraph? That's implementation of the connection, if I'm not wrong. Yeah, connection from new connection. Yeah, that's the connection object. So the connection of all right. Flump. All right. Okay. We have some sense what's the GQL alchemy. It's pretty simple. We're gonna try to implement very similar stuff, and let's now go into Diesel to observe this a bit. First of all, let's see the license. Yeah, it's also Apache, which is fine. Oh, wow. This is a little bit more complex. But okay. Cargo readme, la la la. Connection, how we deal with the connection. This type connects to backend transaction manager. Yeah, yeah, we have here all the constructs from establish is, yeah, that's simple. Yeah, I'm actually interested into these results. So main test establish connection. How do we get that? Where is the establish connection function? Where is that? It's a feature Postgres. Establish connection. If SQLite, then we generate establish connection, and then we have that stuff here that returns the connection. Great. So that's interesting. This is something we would also like to do. So if we build for, so yeah, the whole Diesel idea is to have something which is like database agnostic. So by saying this thing, we're gonna be able to build for Memgraph or the other databases as well. But yeah, which support the protocol as well. Okay, but yeah, basically, yeah, this is compile time function, which will whenever we call that, we're gonna get the connection, and then the object can be used. But that's fine. If you go back under the connection has establish, has transaction. So self transaction manager. So yeah, that's all trait. So the whole connection is a trait that has these things. Yeah, we're gonna do the similar thing. Execute, have a query result object. But yeah, this seems more like a driver than the actual OGM. But okay, it uses the underlying driver to create. Yeah, connection. What do we return? Establish. Once we have function, we execute a function, and function is something that's gonna create queries. Yeah, that's this function. No. Function is gonna get connection and then insert into values, insert into users. And what are the users? That's kind of interesting. What are these users? Schema users DSL. How does this work? pgQuery builder. Okay, implement pgQuery builder. pgQuery builder default. Yeah. Query builder is also some kind of a trait. Push identifier. Push create SQL query. How is that implemented? Distinct on. La 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 la. How to find this schema users DSL? How to find that object? Yeah. How to find that object? user, into users. That's actually like here. Schema. All right. These are actually some test structures to test that table name and derive. Interesting. So queryable. We have these attributes, queryable, identifiable, insertable. That's interesting. I think we need to support that as well. And what is the queryable? Let's say. No. Let's search the entire repo. Queryable type that. Deserialize, create, deserialize, src, deserialize, public trait, public trait queryable stdb, where db backend. Okay, the Rust type you would like to map from. And yeah, I actually don't know in the Rust how these things are implemented. Queryable, sorry. So struct is one that represents the data returned from database query. In many cases, this may not map exactly to the column structure of a single table. Okay. So user, we have a query result user. And once we users load, yeah. And since the user has the queryable, like the load is actually implemented somewhere. And here we have, here is the interesting part. So users.select, and then we have users ID, users email. We know we can reference these fields inside, and that basically the select statement. Yeah, and then the question is where the select is implemented. I need this. So because I don't know how to write these derive macros, I never done that. What? Prots macro derive. Wow, that's advanced stuff. Token stream, token stream. Wow. Yeah, that's a rabbit hole. Maybe I'm gonna spend the entire day researching this. But actually, so let me think, do we really need this for now? Because Memgraph doesn't have strict types yet, so we're gonna return from these things whatever. And they are using that for the mappings between tables and these objects. And tables are where we have well-known structure. Memgraph is not that, doesn't have that good structure, but still we can have that to access stuff. Let me see. Identify, but wait, just to know what that is conceptually, then it's gonna be easier to find what we're looking for. So procedural macro, what's that first? Derive, we need derive macros. Okay, lib. Okay, let's say we're gonna need that. Just add that here for now. Prots macro token string make answer. Prots macro make answer. We're gonna have that as a macro, and then we're gonna do and then we have a basic string that will be parsed and returned back as token stream, and that will be injected. Yeah, basically that's gonna be injected in the whole thing. Yeah, so that's completely unstructured stuff, so we can put like whatever here. Okay, I see. Identifiable. Let's go back and find what is identifiable. I assume that has oh sorry, wrong repo. I assume that has that generate some kind of ID or something. Nope. I've missed that somewhere. Mod identifiable, which means that that's like a module. Yeah. What? These are regular. Oh, this is interesting syntax. What is that? These are parsed columns. Grouping for table columns. Okay. This is something super specific. Joinable. Yeah. Joinable inner. Allow tables. These are in below. Where is that? Ops. Operator allowed. Let me search one more time. These are associations identifiable. These are associations. Oh, here we are. Really? Type ID. Self ID. And where is that implemented? This trait indicates that struct represents a single row in a database table. Nice. This must be implemented to use associations. Additionally, implementing this trait allows you to pass your struct to upgrade. Yeah. Okay, I understand that. But since we have derive, prots macro derive, we have to find that for identifiable. associations. Wow, so it has expand prots macro. Expand prots macro. Yeah, this is some kind of Rust stuff. Nope, it's here. Ah, nice. That's like a function that gets token stream, returns token stream. So you're gonna parse input into emit x into x. Assumption is that x has into syn parse input. Whoa, what's that? Rust syn Rust. Parsing library per sanction is talking to syntax tree of Rust. Nice. Okay, so here we actually parse an input, and input in our case is associations. Derive associations. And what are these associations? What associations? So we have can I get an example of this? So we have if I got this correct, that will add me here like the whole object. Let me just play with this a bit. Procedure macro. Okay, Okay, I'll try to hack a bit. So let me ignore this for now. So this is all working, but yeah, I'm gonna just ignore that for now. Prots macro. Test prots macro derive. The whole crate has to be that. What? Derive answer struct. Really? Sorry, they have like the whole workspace of stuff, so that's all different crates. Derives, diesel derives. Yeah. And now we have that. Oh, yeah, that's a lot. We even need more crates to do so. Yeah, I think I'm gonna go shorter route and avoid all this complexity for now, and then later on we can implement whatever we needed, because this is too complex to start with. But okay, I think we're gonna do that, and then what? Like we need a lib or something. But yeah, I think we're gonna probably need that, so I can maybe start an example here, and then later on we just put stuff here. Yeah. Let's try that. Diesel derives. Yeah, probably it makes sense to do the similar thing. Gasoline derives, and then gasoline. So we're gonna replace src with gasoline, yes. Okay, and here we have, so we need these cargo files everywhere now. This one, we're gonna move that into gasoline. Gasoline, yes, yes. Yeah. So we need to add double here. Okay, gasoline derives. Cargo terminal, yes. Yeah. We need this. Package. We need this. Plots macro true. And then here we need the lib. Lib. Yep, we need this stuff. And here we can put the code. That's gonna fly. So, yeah, we're gonna get that back. This goes under lib. So here under src lib rs. Great. What else do we need here? Gasoline workspace. Yep. This, so I have this here, yeah, but this here has to be completely the workspace. So I explained that when I worked on Mage Rust support. So Rust has these crates, and the philosophy is to have smallest possible code and like single responsibility. Like maybe it's not the single responsibility principle, but they try to the whole Rust ecosystem tries to build a lot of small packages, and for that reason, every crate needs to have like exactly one binary or two, but essentially you have a library or executable or something. And if you need more advanced stuff, then you have to create that concept of a workspace. And our gasoline project will be a workspace type of project, and then workspace has a lot of small crates, and then crates resolve specific stuff. So in this case, the derives stuff will be macros and these let's say advanced stuff that will generate the code that makes sense to me. And yeah, that's just to take an example of workspace. So workspace members. So we need these. So we're gonna completely remove all this. We don't need these. Gasoline. Okay. Okay, we're gonna have gasoline. Gasoline derives. Gasoline should be our client stuff for now. Let me just go back here and return my executable. So that's gonna be the gasoline, and then derives, it's gonna be this. What is? Okay. Great. So we can't use this here, but we can use it here. Cannot find. Yeah, great. We're gonna find you. How is that? How is that referenced? Use. Prots macro examples. Gasoline use derives. Test macro derive. I think that should be it. How to reference these things? Oh no, sorry, no. That's now problem with imports. Second create, yeah. Dependencies. Yeah. Sorry. We need that as a dependency here. So equals path equals nice. Struct never used. Yes. Okay. Nice. Now we have that procedural macro, but how to get the actual code? Item token stream. panic. Rust token stream. Sorry. Okay, I'll just leave that as an example now because it's too complex to go into all these details now. We're gonna spend way too much time on that. Derive test proc macro. Okay, that's gonna struct is not used, but we should have that function here. Yep, yeah, it works. So we have here 42. All right. Okay, if we decide that we need that, we're gonna have that ready. So yeah, nice. We're gonna go back here later on. Don't need these at the moment. Sorry, I forgot to switch. Sorry. Okay. Yeah, I don't know for how long I did that, but okay. So yeah, basically, I've just tried to run this all workspace stuff. Yeah, just to, since I haven't had the code of it ready, so basically we just try to do that gasoline derives stuff. So yeah, we created that procedural macro example, and we created the workspace, and that works from here now. Yeah, I'll commit that so that code will be available here. But yeah, let's go back to the example of the of the OGM. All right. Let's go a little bit back with all this. So diesel, let's go back to diesel. So they have all these things, Docker examples, migrations, la la la. They have a bunch of stuff here. But yeah, how do I connection? We can create connection. Let's find where they generate the actual queries. I assume that's under PG query builder. Let's say for Postgres. So they have a PG query builder. Empty query. Query builder push PG query builder. Query builder. No. Here we are. So select statement mod. So public. So here we have a bunch of stuff. So each select statement can have from, select, default select clause, and then super select clause. Select clause is a whole clause. Yeah, that's super complex. Select clause expression. Query source. Query source, and here we walk AST. That's, I assume, the Rust code that generates that. What is a walk AST? Implement query fragment for select statement where backend a bunch of query fragment for a certain DB. Yeah, and then walk AST self. We push select self distinct OKST. Then we go further, and then here we have the whole visitor of the AST, and then we create out is AST pass db. From where group by having order but here I assume they're they have only the select, but query builder limit, let's say limit clause. That should be super simple. Simple clause, yeah, and that's a macro. Now limit clause, limit clause, limit. What? How do they get macros simple clause? No indent. SQL expression. Here is the expression. Look AST. And what does this reborrow? Is this a Rust specific here, or that's it's not. That's something they defined in the repository. Reborrow. Call this method whenever you pass an instance of AST pass by value. Effectively copy self with a narrower lifetime when passing a reference or a mutable reference. Okay. This is just some helper function. Okay. Let's go back. So yeah, this is quite complex design for us, I would say, at this point, even though I think it's quite robust. It has a bunch of stuff included. I think I'll try to go with the simple stuff, just wrapping connection and building objects, and then implement a simple query builder. Okay, let me just go back here. This is much simpler. So how do we do this? No variables have been matched. We just serialize variable and properties. Construct query, self variable, self labels, self properties. Yeah, and that's a node partial query. Okay, edge partial query. That's directed variable labels properties, and we have these minus stuff. Yeah, match. So labels properties, two Cypher labels, two Cypher properties. Boom, append. And then these functions are just, so match has a node and it returns the same query. Yeah. All right. And then match can have additional stuff. Node, we are just composing like a pattern for the match. Query append. Yeah. This is much simpler. Get single. What is that? And what about create? We don't have. Yep. Yeah. Basically, that's much simpler design, and we just are essentially dumping this stuff in a string, and then we execute that. Yeah. Yeah. Okay. I'll be right back. And I'm back. So yeah, quick tip from our sponsor. So this live stream is brought to you by Freshwater. All right, let's try to do at least something meaningful. A connection object. So we're gonna do all that into this thing here. Connection params and connection. Let's go back here and just see. We just take this simple stuff and we create execute and fetch is active and create. Okay, these guys have, I assume, connection, yeah. Trait. Pub trait, and we return, okay. Pub trait, pub trait connection, and yeah, we're gonna just follow the design here for now. And so execute and fetch is active. So connection has, so execute fn execute, we have a query. These traits, do they have self? Yeah, they have self query. We're gonna just use string ref and that's it. Str, and this returns what we're gonna return. We're gonna return result. Result nothing. What is called here? Execute and fetch. Str iterator dict string any. Now that's gonna be a bit more complex because we need to find the return some result. Yeah. We need some kind of a result. Yeah, and for that we need another model what we're gonna have here. So value. Let's just take the value from here. We need this, but we won't have exactly the same stuff here because we need what? All right. We need a value. Okay, do we store that value here? Node. Aha. Each object here is a bit more does to string trait. Okay. Okay. Is it a string to string? So value yeah use std okay, so impl value, yeah, to string self let's just model simple stuff first. So just ignore everything else here and just create this. So match Sorry, I forgot. Define the match control, match. Yeah, match self. No, then format. Else, for everything else we just return yeah, for everything else we return will that fly? Okay. Okay. Why this doesn't work now? Create model. What's the state now? Or an operator result identifier. What? Self null value null. Okay. Found reserved identifier. What's wrong here? Coin. Do I have to cover everything? Probably, yeah. Okay, let's resolve it for now. What is this? A variant is never constructed. Yeah, okay, fine. Okay, but I have to start. I can start writing tests. Couldn't find model in the create root. How come? Pub model. Uh-huh. Uh-huh. I'm still a bit confused with this. Yeah, okay. Yeah, Gazelle model value. Yeah, we're gonna do that under there. So I'll just I'll remove that from here and start writing tests immediately for these. Okay. Here we have a bunch of stuff. No. Wait, did I lose that? No. Anyway, we're gonna write it again. Doesn't matter. Okay, let me just take similar structure as we have here, just for the tests. So for the tests, include tests. So this is here. If we want to move tests under the tests file, and tests.rs. Okay. To import these things, test just need the first line. Test, and we have simple test, then test null to string, assert equal. So value to string has that from. equals null. Will that work? Sorry. Yeah, okay, that works. And let's write other tests. Bool out of. Will that actually work? Failed, true, left, true, null. So yeah, we can also slightly change that here. So okay, I need if statement. We don't need that. We don't have that operator, but yeah, we have this if x, then we return true, otherwise we return false. What is wrong here? Mismatch types. What? If x true, false. Okay, nice. Bool to string. Model tests, bool to string, yeah. Okay. To string. And string to string. String to string, ABC. These are pretty basic tests, but yeah, later on we're gonna have more complex stuff. Okay, we also need to the reference here. What? Oh, string found. Huh. Actually, no. Float. Float doesn't work. Format. Interesting. 1.1. What's we gonna do here? Yeah, okay. Anyway, that's it. So okay, we have these values. Connection. Back to connection. So just a second. How are these objects actually translated into something? So connection. GQL alchemy, connection. Convert memgraph value. Convert memgraph value. If it's value, there is a method to convert that. Studback. Studback. Stud of value. Stud error. Stud error. What? Again, the same problem. We actually have that resolved in the mage. Let's go back here under Rust. I still haven't realized why these things happen. Result. MGP error is actually an enum. Rust. Result. Yeah, not sure what we should use here. Static string. Yeah. Let's for now just put. Yeah, we're gonna just create another enum and that's it. All right, we have that trait, and we're gonna also implement pub struct memgraph. So we have host, which is a string. We have username. What else we have? Host username, password, SSL mode. Host port, username, password encrypted. Host port, that's E32. Bool and encrypted, and that's it. Okay, and then implement Impala connection for Memgraph. yeah, connect. The size of value type. Yeah, yeah, because that's not known. Yeah, that's not gonna fly. So how do I return? If I actually return memgraph, that's fine. Yeah, this is a bit hackish now, but yeah, I'll just return memgraph for now. Then we're gonna recreate that later on. Fetch, execute, and fetch self. All right. Why? Why do we have this? Okay, that's fine. So we have to connect first, and that's gonna be done by running the same stuff as here. Connect to memgraph. Yeah. Since I have self, I'm gonna do, yeah. So a host self.host port self.port username self.username encrypted self.encrypted. The rest is default. We now have connection. But we have to store that connection as well. Rust std option. Std option. Connection params connection. Connection. Unused import connection. Okay, what about here? Self.host connection params. Okay, I should change that to E16 to unsigned integer. That's fine. Then this should work. But you have optional stuff here. What? It's not under. Yeah, that's not great. Okay, I need to store that connection object somehow, and the question is where. Interesting. Diesel actually has a nullable struct. That's something SQL specific, which is fine. Doesn't matter. We're gonna just, for now, I just want to compile that. Boom. Mismatch type, mismatch type. It's not encrypted, it's something uses SSL or something. SSL mode. Okay. Require disable. Require else cell mode disable. Okay. Vector of just return something and execute. Okay. Okay, what's the problem here? Connection is defined multiple times. Okay. Rsmg client connection, maybe it's a better thing to use, yeah. Directly connection. So here, instead of connection params, Rsmg client connection params, rs client that, Rsmg client that, yeah, connection Rsmg client that, yeah, that's not gonna fly. Match if okay, C, then do okay, self error, error, gasoline error. Connect. Okay, connect failure, yeah. Gasoline error, connect failure. Okay, mismatched types. What's return memgraph? And That's the problem, because I could return self, but I can't return result self. Sorry. How to do that? Yeah, I need to box that. Yeah. If I put box here, that's gonna fly. Std boxed new, box new, box new. Oh no, I have to return. Psst. Yeah, if I return. Yeah, if I return just memgraph, that's not good. Rust return result self. Each type in the function option here is the type. Allowing unsized types to be used in trait methods is the key part of allowing by value trait objects. For example, f and once. Yeah. Not option, I want result. Yeah, what are the options here? I'm not sure how to. only if memgraph object can be and can contain an error as well. Yeah. Result value. Okay, one option is to memgraph object value, but yeah, maybe I don't need that at all here because I'll have to execute something against that. Yeah. And the state. Memgraph object contains connection and the state. Yep. Then we can return it here. Just for the sake of test, if we put here self and then here we return that self. Panic. Okay. Now we don't have the copy here because that will try to copy stuff, which is not great. If we do here this, that's mismatch type, yeah. Pass this here. Aha. I'm stupid. Maybe we can put here. What about that? Missing lifetime specifier. Aha. Aha. Cannot move. What if we clone all that? Yeah. If we return the same reference here. Unused variable C. Used variable E. Okay, yeah. Okay. Connection. Connection. And that's mutable. If OK X expected member found empty. What? Expected memgraph. Aha. Aha. Found empty. Rust. Connection. All right. That returns like totally new connection. Okay. But if I I have that connection reference. Some C. self is a reference, so the data it refers it cannot be written. Mutable. Field is never read connection. Okay. Great. And then execute and fetch. So here, okay, so I was a little bit in silence, but yeah, here I'm trying to figure out how to actually deal with the Rust stuff. And yeah, Memgraph object is gonna store the connection object as well. And yeah, we'll try to create that for now. And an idea is to now execute and fetch stuff from here. Okay, so okay, let's go to the example here. I'll actually try to do this. Okay, connection execute self dot. So to execute, we need to fetch the connection, and we have that connection. And we're gonna execute the query. Query is here. We don't have parameters at this stage. So we're gonna just query. We're gonna just do query. Columns nothing. Fetch all. We have that. So for each record, it has to be transformed into these objects. And the problem is that we have multiple results. So we need some kind of an iterator. Haha. Yeah. For now, I'll just return vector of vectors. std vec fetch all. We need to transform these values, and the values is Rsmg client value, and yeah, Rust std vector. Yeah, we're gonna just do that. So for each record we need a new vector, and then for each value we're gonna push into that vector, and we need another vector here, and yeah, so result vec, let's call it here record vec. I'm gonna optimize all that later on, but just to have something working. This is not optimal at all, but yeah, good enough for now. So record vec dot push and match value, but value is Rsmg client value. Rsmg client value value null. If it's null, we return value null. If it's int x, we return no bool. So we have int, we have float, we have string. Int, float, string. Okay. Record vec. Okay, and we take result vec and push record vec. And then we return okay. No. We also have self connection commit. Self connection commit. That's gonna fail to compile because we need to handle this differently. If okay, we just return result vec. If error, we need another error. All right. Option. Yeah, I have to think how to propagate. Match, okay. For okay, do nothing. If error, execute and fetch error. Fetch error. Gasoline error. This pattern has 0. Result has an incompatible type for this trait. Really? Fetch all dot unwrap. That's gonna fail. That's gonna fail. Match connection fetch all. What? Okay. Error. Self dot connection dot unwrap. Has incompatible type for trait. Gasoline error. Yes. Model value found. Result of a model value. What? Okay. I've changed only on one place. In one place. std vec value. What is wrong now? Ah. And now unwrap. Take value from option Rust. What's the most efficient way to get that value out of it? Yeah, unwrap. Yep. All right. Can't borrow is mutable. Sref. Why not? Row S is immutable. No. Is the option? No. Sref. Yeah, I don't understand now why I cannot take that reference since Because connection params self dot connection some C. I think I just have to take as mut as ref as mut. What's gonna happen in this case? Self is a reference, so the data it refers can be borrowed as mutable. We take that as a mutable. That's gonna fly. Mutable. Wow. So okay, we actually managed to compile. All right. So now we're gonna execute and fetch against memgraph, and we're gonna get these values back. Okay. So okay, test prods, not that this. So instead of using all this, we're gonna use our stuff. Gasoline. Gasoline member. Let memgraph equals I'm gonna later fix this encrypted false. Okay. Even though we are writing the query builder, we are not there yet. We are just wrapping simple stuff. But yeah, gasoline error. No memgraph in the root. Why not? Since we should pub struct memgraph, let's put stuff here. We need to do similar as here. Pub use gasoline connection and doesn't matter, so we're gonna just method not found in memgraph. Really? Okay, option, la la la. We need to put some here. So I'll later optimize that. Now I just want to get something that's going to work. Missing field connection in. Execute and fetch. Probably it's not public or something. Yeah. Implement, execute, pub trait, la la la. Connect pub. What's the problem then? I've really not execute and fetch. Execute and fetch. Query. The method. Item structure can only be used if the trait is in scope. Connection. Yeah, that's correct. Cannot borrow memgraph hospital, and it's not memgraph let mutable let mutable error, unused error. Target debug gasoline. Not yet implemented. Yeah. Let me check what do we have. Yeah, we have nodes and stuff here. So and yeah. And 1 1 2 2. Okay, and yeah, match and return n. That's gonna return me. No. Sorry, not gonna fly because we don't have support for that. So we're gonna delete all these things, and in addition, prop, copy that and create like prop. Yeah, and then return n dot prop. 2. Yes. Okay, it works. Because we have 2 nodes and we are getting that vector of values. Okay. So yeah, oh, it's already, yeah, I'm already 3 hours in, which is quite long. So yeah, do I stay or do I go? At this point, we just wrapped. Basically, we didn't do much. We just wrapped the whole Rsmg client in some kind of a wrapper. It's not perfect. It's far from perfect. But yeah, it has some basic building blocks. Yeah, I think I'm gonna stop here for now. And yeah, that's it. Okay, I'll just make a, yeah, I'll just push that FMT. Okay. So we have workspace, we have to-dos, all to-dos are still open. We started the package in gasoline stuff. We have Rsmg client here. That's fine. We have values. We have that. We have that. And we have conversions. We have some basic tests. We have the procedure macro, and that's it. Yeah. Okay. Yeah. I think I'm gonna stop here for now. And yeah, let me just format that. All good. Minus b add int init, just init. All right. Yeah. GQL alchemy. I go back to gasoline requests. Yeah, it's there. Okay. All right. Yeah, as always, when you go with completely new stuff, it takes much longer than expected. But yeah, we made some progress. No questions, as always. You guys you guys have to start asking questions. I would really like to get some engagement. But yeah, hopefully this was useful. Yeah, I'm still figuring out the Rust stuff. I'm still not super skillful with it, but yeah. And yeah, it's always a challenge to make a compiler be happy, but that's how it is. All right. What next time? I think next time I'll continue this, but yeah, I'm pretty confident I'll have something finished by the next time. And yeah, thanks everyone for watching. Have a good rest of the weekend, and yeah, bye bye.